A bar chart, also known as a bar graph, is a diagram that shows categorical data, rectangular bars, where the heights of the bars are proportional to the values they represent. It is the most widely used graphical method of data presentation. In this video, we are going to learn everything about bar graphs, from defining a bar graph, to the uses of a bar graph, to the properties of a bar graph, parts of a bar graph, types of bar graphs, how to construct a bar graph, horizontal versus vertical bar graphs, and lastly, advantages and disadvantages of bar graphs. So what is a bar graph? A bar graph is a pictorial representation of categorical data using bars. The height or length of each bar is proportional to the frequency or the quantity of the underlying data value. The bars can either be displayed horizontally as horizontal bar charts or vertically as column charts. These bars help to give a visual display for ease of comparing quantities in different categories of a variable. A bar graph is arguably the easiest diagram to prepare as it does not require much effort. Uses of a bar graph. Bar graphs are used for comparison between different categories of one or more categorical variables. For example, if you wanted to compare the frequency of symptoms in patients with COVID-19, here we have a variable called symptom, and we're using a bar chart to compare the three categories: fever, headache, and cough. Bar graphs can also be used to compare data sets that are independent of one another. For example, number of doctors in America versus the number in Nigeria and the number in the UK per 1,000 persons. We can see that these data are independent of each other and can still be represented using a bar graph. Awesome. So what are the requisites of a bar graph? For a diagram to qualify as a bar graph, it must have these 6 properties. The first, it must have 2 axes, the vertical and the horizontal axes, also called the y and the x-axis respectively. Number 2, all bars should have equal width. And then number 3, all bars should have equal space between them. Number 4, the height of the rectangular bar should be equivalent to the data it represents. Number 5, the bars must always be on a common base. And then finally, the bars can be drawn either vertically like we have here or horizontally like this. Easy peasy. Components of a simple bar graph. There are 4 key elements that work together to communicate information effectively in a simple bar chart. Number 1 is the title. This should always be a clear and concise description, usually placed below the chart. Great, that's number 1. Number 2 is the axes. There are only 2 axes in a simple bar graph, the x-axis and the y-axis. The x-axis is the horizontal axis, which typically represents the categorical variables being compared. So let's tag this here. And the y-axis is the vertical axis. This shows the numerical scale corresponding to the values being represented by the bars in the bar diagram. And let's tag this also here. And this could be frequencies, proportions, or percentages. And then number 3. Number 3 is the bars. These are rectangular bars representing the data. The height of each bar represents the value of each category. So each category of categorical variables is represented by a rectangular bar, and the length of each bar corresponds to the numerical value of the category. And this value is read on the y-axis. So let's tag this bar as 3. Awesome. And lastly, for number 4, we have the labels. These are all the text annotations that provide information within the chart. First, we have the axis labels. These are labels for the x and y axis, specifying which kind of data each axis represents. The x-axis usually carries the variable, so it must be labeled as such, and in this example, the variable is symptoms. The y-axis carries the numerical values, which, as I said earlier, may be counts or percentages, and in this case, it's the frequency, and that's just a fancy name for the count. Yes, let's add these tags so we get it clearly, here and here. Great. Next is the category label. These are labels on the x-axis for each category. Since every bar represents a category of the categorical variable, then each bar must be clearly labeled with the name of the category. In this example, the variable is symptoms of diphtheria, and it has only 4 categories according to the data: sore throat, bull neck, weakness, and fever. So each category must be labeled correctly. Let's just tag one of the categories. Nice. And finally, the data labels. These are numerical values for each category. This is usually displayed on the top of each bar to show the exact point that it represents on the y-axis. And this may be frequency, proportion, or percentage. In this example, the scale of this graph is from 0 to 10 on the y-axis. So putting the numeric values on each bar will look like this. And let's just tag one of these values. Awesome. Now it's your turn. Here's a question for you. Do you think we should have a legend in a simple bar graph? Yes or no? And state the reasons for your answer. Please put your responses in the comment section below. Alright, so these are the four main components or elements or parts of a simple bar graph. The title, the axes, the bars, and the labels. There are several types of bar graphs depending on the type of data you want to present and the story you want to tell. The three most common ones include a simple bar chart, multiple bar chart, and component bar charts. In a simple bar chart, the bars represent the whole of the magnitude of a single categorical variable. The height of each bar indicates the value of the category represented. So in this example, we see that we have one categorical variable, which is symptom, and it has three categories, and each category is represented by a bar whose height indicates its frequency. The multiple bar chart, unlike the simple bar chart, is used for comparing data of two categorical variables. The categories of the first variable form the main categories, which are separate groups of bars. Then the categories of the second variable, i.e. the subcategories, are represented by individual bars. The distinguishing feature for this type of bar graph is that we see distinct groups of bars. Each category of the first variable is represented by multiple bars, hence the name multiple bar chart. Each bar within the main category represents the subcategory. In this example, we can see that we have two categorical variables, symptom and gender. Symptom is the first variable with three main categories: fever, headache, and cough. Each main category is a distinct group made up of multiple bars. In each group that represents a category of the first variable, there are two bars each representing subcategories of the second variable, gender. So in this group 3, for example, the main category is cough and the subcategories are male and female. Notice that the subcategories are usually given different colors within a group and the same colors between the groups. This is to aid the comparison of subgroups between groups. So for example, we can compare the data for all the males looking at only the yellow bars. Awesome. And finally, we come to the component bar charts. This is also used to represent two categorical variables, but here the bars representing the categories of the first variable are subdivided into components representing the categories of the second variable, i.e. the subcategories. There are two types of component bar charts. The first is called the actual component bar chart, and then the second is the percentage component bar chart. In the actual component bar chart, the actual frequency or the value of the main category represents the overall height of each bar, and the actual value or frequency of the subcategories represent the height of each component, and that's why it's called actual. So in this example, if there were 7 individuals with fever, 4 males and 3 females, then the height of the whole bar will be a frequency of 7. That's 7 units, right? And the height of the male part, that's the yellow part, will be 4 units. And that of the female, the red part, will be 3 units. So you see the actual frequencies are being used here. This type of component bar chart is also called stacked bar chart because you can see that one component is stacked on the other. On the other hand, in the percentage component bar charts, the length of the individual components represent the percentage of each component from the overall total of each category. Notice that all the bars are of the same length and they are all 100%. So in this example, with the same data as the previous example, we know that there were 7 individuals with fever, right? And for the percent bar chart, this 7 is converted to 100%. And if 7 is 100%, and we know 3 out of 7 were females, what percentage is this going to be? So this will be 3 divided by 7 times 100, and that will be 43%. And for the males that are 4 out of 7 individuals with fever, this will approximately be 57%. So you see here, the actual values are not represented, but the percentage of the total for each category. The size of each component is the proportion of the total. This type of component bar chart is also called a 100% stacked bar chart because you can see all the components are stacked up to 100%. Awesome. Now you know the different types of bar charts and the kinds of data to use for each type. How to draw a simple bar graph. This is the data of the distribution of the symptoms of 24 cases of children with diphtheria admitted into the pediatric ward of Ahmadu Bello University Teaching Hospital, Shika, Nigeria. To present this data in a bar graph, the first step is to write the title, Distribution of Clinical Features of Patients with Diphtheria Admitted into the Pediatric Ward of ABUTH. Next is to draw and label the axes. So the symptoms will be represented on the x-axis and the frequency on the y-axis. The next step is to determine the range and the scale. We know that the data ranges from 2 to 9, so a scale of 0 to 10 will do. And finally, we draw the bars to represent each category. For the first category, sore throat, frequency is 9. The second, bull neck, frequency is 2. The third, weakness, frequency of 5. And the fourth, fever, is 8. Now we have a bar chart and we can visually compare the values of the data. We see clearly that the most common symptom was sore throat, while the least common was bull neck. Easy peasy. Horizontal versus vertical bar graphs. A bar graph is a diagram made up of bars whose heights or lengths represent the frequencies of the different categories of data. It is used to compare two or more values of categorical variables. Bar graphs can be oriented either horizontally as horizontal bar graphs or vertically as vertical bar graphs, also known as column charts. Though vertical bar graphs are more common, horizontal ones are easier to read since the layout is just the same as how we process information, as many people read from left to right. The horizontal bar graph is a better choice for variables with long category names because there is more space on the left side of the chart or the long axis labels. This is usually the case when you have nominal data. Vertical bar graphs, on the other hand, are used when you have ordinal data. So let's look at this example of a categorical variable, reasons for not receiving the diphtheria vaccine. This variable produces nominal data with the categories having long names, and we can see the corresponding percentages for each category. If we wanted to represent this using a vertical bar chart, we would have had to put the long category labels like this, where there is no much space at the bottom, or we may have even seen people putting the long categorical labels diagonally like this. So we have long labels here and diagonal labels here. This is a big no-no. Please never do any of these. Putting it like this is very difficult to read and is also not visually appealing. It defeats the purpose of a bar graph. If you have to put categorical labels diagonally in a vertical bar graph, or you have to put long label names like this, then a horizontal bar chart is a better choice for such situations. Period. This situation is a perfect example of when to use horizontal bar graphs. So putting this correctly, our horizontal bar chart will look like this. Whoa, looking cool and nice. And now you can see we have been able to use the space on the left to write our label names clearly. Awesome. On the other hand, if your data was ordinal, meaning the categories have a natural order, a vertical bar chart is a better choice because placing the bars vertically from left to right in that order is more logical. For example, the age group of women attending antenatal care will be better put in a vertical bar graph like this. We can see here, irrespective of the frequency, each group must be arranged in the correct order from the smallest age group to the largest age group and from left to right. Awesome. So to recap, bar graphs could be oriented either horizontally or vertically. Horizontal bar graphs are easier to read and mainly used for nominal data or in situations where the categories have long names. While vertical bar graphs, though more common, are mainly used for ordinal data. Easy peasy. Advantages of bar charts. Bar charts come with several advantages that make them a popular choice for data visualization. Number 1. They're easy to understand. Bar charts are arguably the simplest charts to understand. People are naturally good at comparing the lengths of bars, making it easy for them to note which category has the highest or lowest value at a glance. So bar charts can be used for a broad audience as no prior knowledge is needed. Number 2, they're effective for making comparisons. Bar charts are very useful at showcasing comparisons between different categories. The use of bars with a common baseline allows for a quick visual assessment of how much each category differs from the others. Flexibility. Bar charts can be adapted to represent various data types. They can handle nominal data, For example, symptoms of a disease, or ordinal data, that's data in ranked categories, like age groups. This makes them a versatile tool for presenting information across various fields like medicine, public health, and statistics. And lastly, customization. Bar charts are easily customized to enhance clarity and visual appeal. You can use different colors for each category, add labels, incorporate data values on top of the bars for a more informative presentation. So these are the advantages of a bar chart as a tool for data visualization. It is easy to understand, it is effective for making comparisons, it is flexible, and it can be easily customized. Easy peasy. Let me know in the comment section which one of the advantages you like the most. Though bar charts are great for many tasks, they do have some downsides to consider. The first is their limited ability for data display. Bar charts focus primarily on showing the magnitude of different categories of a single variable. They do not effectively represent the underlying data distribution, outliers, or variability within a category. This can be misleading if the data within a category is spread out. Number 2. Complexity with many categories. When dealing with many categories, bar charts can become cluttered and difficult to interpret. The limited space on the x-axis can make it hard to distinguish between bars, hindering clear comparisons. And number 3, there's a huge misinterpretation potential. Bar charts can be susceptible to manipulation by changing the scale on the y-axis. A drastic change can exaggerate or downplay differences between categories. Look at this example with the normal scale on the y-axis from 0 to 70. It's exactly the same data I plotted here, but this time I adjusted the scale to start at around 35. Do you notice how it exaggerates the difference between fever and headache? So bar charts can be manipulated to exaggerate or downplay differences. And finally, bar charts are unsuitable for continuous data. While they can work for certain continuous data with clear categories, e.g. age ranges, bar charts are not ideal for showcasing data with final gradations, e.g. temperature variations or the rest. Line charts are better suited for continuous data. So these are the disadvantages of bar charts. They have limited ability to display data. They can have complexity when you have multiple categories. They have a misinterpretation potential and are unsuitable for continuous data. Easy peasy. Let me know in the comment section if you have ever used bar charts before and what your experience was. In this video, we have been able to explain everything about bar charts, from the definition of a bar graph, uses of bar graph, the properties of a bar graph, parts of a bar graph, the types of bar graphs, how to construct a bar graph, horizontal versus vertical bar graphs, and advantages and disadvantages of bar graphs. Now it's your turn. What kind of bar graphs will you use to represent this data? 1. The level of malnutrition. This is categorized as nourished, mild, moderate, and severe in a sample of 100 children in a village in Zaria. 2. The level of malnutrition in a sample of 100 children in a village in Zaria, but this time categorized by sex, male and female. And 3. The sex distribution of a sample of 100 children in a village in Zaria, indicating their proportion with the different levels of malnutrition. Please put your answers in the comment section below and do not ignore. Now, if you gain value with this video, please drop a like and subscribe for more content like this. And if you want to learn more about the advantages or merits of pie charts, then check out this video here. And for histograms, check out this other video right here. See you in the next video, and as always, thanks for watching.